All right, hi everyone. So we are going to do our 4.7 notes today. This is inverse trig functions. Again, a review on our trig stuff from last year. So we're going to start with some graphing stuff. Now, I don't want you to freak out because we're not really going to be using a lot of this, but I just want you to see the background of where all of these rules and stuff comes from. All right, so we're just going to do a quick review on how you graph sine. So if I remember right, sine starts at 0, 0. So there's my little dot for 0, 0. And then by pi over 2, it goes up to 1, and then back down to pi, and then down to -1, and back up to 0. And it does the same thing in the other direction, down to there, up to there, up to there, and down to there. So it's going to make this nice wave pattern. All right. So you might be thinking, okay, Power, how did you know it was all of those? Well, we'll get to that in a little bit, and hopefully Miss Mitchell has already talked a little bit about this, but if not, we'll go over it. Okay, so the next thing that I want to do is look at this function, and I know that this continues in both directions, right? So is it a function? Yes, because it passes vertical line tests. There's nowhere where I could put a vertical line through it or would touch more than once. So it is a function. And what's its domain? Well, from left to right for the x's, it can go everywhere. The arrows say so. So that's -pi to pi. And then the range, it looks like it only goes down as low as -1 and up as high as regular 1. And do they actually reach those points? They do. So they get brackets. All right. So how did I know where all of those dots were? Well, I'm thinking about my unit circle, and that when I'm over here, this is called 1, 0. And the first letter or the first number in that coordinate is considered cosine or the x, and the second number is considered sine. So when I'm here, sine would start at 0, 0. And then notice that the next one is pi over 2, which is 90 degrees. So when I'm up here, it's 0, 1, and now you can see that sine is now positive 1. And when I get over here, it's the same as pi, and now I'm at -1, 0. So now again, sine is the 0, so it's back down to there. And then at 3 pi over 2, I'm looking at this is 0 and -1, and again, the sine is the -1, that's that one. And then I've made my way around the circle and I'm back to where I am. So we're purposely picking the numbers that are on the axes to make it really easy, so we're only basically graphing zeros and ones. Okay, on this side, I'm going to go ahead and I'm going to graph the inverse. Now remember, all that that means for an inverse is that I am switching my x's and y's. Let's make that a little bit of a different color. Okay, so if I'm switching my x's and y's, it still starts at 0, 0, right? But then here it was pi over 2, 1. Now I'm going to do 1 pi over 2. The next one was pi 0, so I'm going to do 0 pi. And you can kind of see that the same pattern is starting over here. We're going to get this nice little wave pattern going on over here. So after that, my next one is going to be at -1 and then back at pi. So we've just got basically a sideways wave going on here. And if I continue down, I have this one, and then it goes back down to here, and then it goes back down to here, and then back down to here. So you can see it's still basically the same graph, right? Except all the x's and the y's have been switched. So is this one a function? Well, actually, no, because if I put a vertical line through it, I'm going to pass through this graph more than once. So here's the thing is, what do I have to do in order for it to be a function? How could I chop it up? So here's our thought, is we always want to start near 0, okay? And then if we have a choice, we'd like to go up versus down until we run out of room for it to pass vertical line test. So if I start right here and I go this way, I can make it up to here before I have the problem of the second I go backwards, it's going to not pass vertical line test. Okay, so notice that's from 0 to pi over 2. So 0 to pi over 2 is quadrant 1. And then if I go any further into quadrant 2, it's going to not pass vertical line test. So I'm going to go the other way as well. And now I'm going to try to go this way and see how far I can get. I can get this far before I would have a vertical line test that wouldn't make it. So that would be going this way on the unit circle. So that would be quadrant 4. So we're going to say that's quadrants 1 and 4. So our actual inverse trig function only exists from here until here, and then it stops. That's it. Okay, so what's its domain? Well, now its left and right goes from -1. All right, back it goes. The domain goes from -1 until 1. Does it actually reach those? It does. And the range are the y's, and the y's it goes from is -pi/2 only up until pi/2. Does it reach those? It does. So notice whereas the original trig graph will go and have a domain that goes everywhere from infinity to -infinity, inverse trig functions, because we want them to be functions, have to be chopped up, otherwise they won't pass vertical line test. Okay, so that's the main concept here. We're just going to go through each one of these. Again, you're not going to have to memorize this as much as just understand where they come from. We'll give you some rules in a little bit that makes this easier. All right, so here is cosine. So cosine. Let's do cosine. So again, on cosine, I know cosine starts at 1. So again, I'm doing unit circle stuff. I'm starting right here. This is 1, 0. Cosine is the 1. Then when I go up here, I'm at 0, 1. Cosine is the 0, right? And then I know it's going to do the exact same thing again. It's going to come down to here, go back up to here, go back up to here. And then same thing on this side, here, then down to here, then back up to here, then back up to here. So again, you can see that's the same wave pattern. It's just the wave has been moved off a little bit, right? And it's going to keep going. So is this one a function? Well, yes, I could go anywhere and draw a line and it would pass vertical line test. Its domain is everything, all real numbers from left to right. Its range, again, only goes from -1 to 1, and it does actually hit those points, so we get brackets. Okay, so now we're going to go over here and look at this one. So on this one, if I switch these over, instead of 0, 1, it's going to become 1, 0. So we're going to start here. Then this one was pi/2, 0. We're going to do 0 pi/2. Then this one is pi -1. We're going to do -1 pi. Then this one is pi/, what is that? 3 pi/2 with a 0. So we're going to do 0, 3 pi/2, right? And we can kind of see that it's the same pattern here. So this one goes to here, this one goes to here, this one goes to here, this one goes to here. And we're doing this exact same thing again, except it's going sideways, right? And again, it's not going to pass vertical line test because of how many times these waves cross back over each other. All right, so what do I do? All right, so let's go back and look at this one. I want to start at 0. I want to go up in the positive direction as far as I can until it doesn't pass. So this time I'm going to be able to go all the way up to here. And then the second I go past that, I would not pass vertical line test. Okay, so where is that? Well, that is from 0 to pi. So if I started here, this is pi/2. I went right by it, and here's pi. So it looks like I'm going to be in quadrants 1 and 2. Now you might be thinking, yeah, I could have also gone the other way, but could you? Right? If I start at 0 and the choice is if you have a choice between positive or negative, you take positive first, then I really shouldn't have gone down to the bottom part at all, right? Because that would have caused a problem. So we always start at 0. We always go to the positive direction first until it no longer passes vertical line test. Okay, so looking at that pink part, the domain is still from -1 to 1, except now the range, the y's, are going to go from 0 until pi. That's slightly different than what we did for sine. So we're going to have to remember which quadrants work for when. Again, I'll show you an easier way to do this in a second. So we're starting to get the idea that all we're talking about in inverses is we're flipping them over to get from here to here, and then we're chopping them up so that they actually form a function and pass vertical line test. All right, so our last one, tangent. These are the big ones that we talk about each time. All right, so on tangent, if I start here at 1, 0, tangent is sine over cosine. So sine over cosine would be 0 over 1. So that's 0. Okay, now the next one is pi/2. By the time I get up over here, 0 over 1, if I do those as a fraction, 1 over 0, defined. So that means that's going to be an asymptote. So what's between there? Well, let's go and try something right about in the middle. Let's go and try a 45-degree angle. So remember, these are going to be like radical 2 over 2s, but when I put them over each other, radical 2 over 2 over radical 2 over 2 is going to be a 1. So halfway between those, I'm going to be at 1. And then every time after that, the top fraction is going to be bigger. It's going to keep going up like this. And since it's an asymptote, it's just going to keep going up like that forever. We're going to have the same problem going the other way. So when I get to here, I'm going to be -1/0. That's fine. That's going to be a 0. So at negative or at pi, it would be back to here again. Okay. But what happened in between then? Well, if I go and I check out this one would have been a -1. So it would have been down here. So you can see that if I do these and then I get down to this one's undefined again. So what it looks like is I'm getting 2 halves of a parabola happening here. And so in between these asymptotes, it's going to kind of look like this. And every pi/2, we're going to have an asymptote. Okay, so it's just going to keep repeating like that. So I'm going to just mainly focus on, let's see, I'm going to mainly focus on this first grouping that goes from here to here. Okay, and we're going to write that one up. So is this one a function? Yes, vertical line test is passed. What is its domain? Well, this time its domain, I can't really do everything because there are asymptotes where nothing exists, but we're just going to look at this first one. So the domain is from -pi/2 to pi/2. Did I actually get there? I did not. So those need to be not brackets, but parentheses. What's the range? Well, the range goes all the way down from -infinity to infinity. So we've got those going for us. All right, so now let's switch over and let's do the inverse. So it's still going to go through 0, 0. We're still going to have asymptotes, but they're going to be now horizontal at those 2 places, right? And so now I just have to figure out at pi/4, I was at 1. So when I flip that over, it's going to be 1 pi/4. So 1 pi/4. So it's going to go this way. So this way, and then this one would have been -1, so this one goes this way. So again, we're just going to focus on the ones between here and here, okay? And again, just like we did before, we're going to look at this for, is this on its own a function? Well, if I had multiples of it, it would not be, right? Because we would have extra ones that would also be over here, and it'd keep going, and over here, and it'd keep going. You get the idea. All right. So is it a function? It is not a function. Okay, how could we make it a function? Well, if I start here and I move upwards, I'm good forever, right? Okay, but that only gets me, if I start here and I go up to pi/2, I'm good, right? But could I have, see, now I'm going to keep going forever. I can't jump over that asymptote, right? Because that's moving a whole entire different part. So this is the first time where you're allowed to actually go and continue it in the negative spot because we hit an asymptote. So if I go this way, I'll get all the way down to -pi/2, which is just going the negative direction around the unit circle. So I would get this one. So we're looking at quadrants 1 and 4. But the same main idea still exists. I'm starting at 0. I'm going up to the positive direction if possible. And then since I hit an asymptote, I'm going to go ahead and continue it. And as long as I stay between these asymptotes, it's going to pass vertical line test. Once I pass an asymptote, I'm going to get repeating things that don't pass anymore. All right, so we've got those two. So the domain just for that middle pink one is everything. And the range for that one is going to be from -pi/2 to pi/2. Because it doesn't reach there, it's just parentheses. All right, so that's the background information. You don't really need to worry too much about this, right? Because we have some shortcut methods to help us. So let's go do some shortcut methods. Okay, first one is looking at this quadrant thing here. Remember that this is how we number them. It's as if you're drawing the number Q. So if you try to draw the number or the letter number Q, if you try to draw the letter Q, that's how I draw it, is I start at the top and then I go here. Well, that's the same numbering system. If I start at the over here and go around this way and then put the Q in it, this will be quadrant 4. Okay, so it's 1, 2, 3, 4. All right, so we actually know a few things about quadrants, right? We know that they're divided into 4, that often the signs change of different trig functions depending on where I am in the quadrant. And you probably remember learning something about all students take calculus. So that was a way to remember, and A stands for all trig functions are positive in that quadrant. Okay, S is only sine of the big 3 is positive in that quadrant. T is only tangent is positive in that quadrant, and C is only cosine is positive in that quadrant. That means of the big 3, if I'm in quadrant 2, sine is going to be positive, but cosine and tangent is going to be negative. If I'm in quadrant 1, I don't have to worry about anything. All my trig functions are going to be positive. Okay. All right. So over here is our general unit circle. So remember when I was saying don't worry too much about it, and I was showing you where I was around the unit circle. That's kind of like your reminder of where I was. Okay. And over here, I put down 3 circles for us. Okay. So 3 circles for us. Let's see, what could I use those for? Let's do the first one for sine. Okay, and you tell me when sine is positive around in these quadrants. So I know that sine is going to be positive in quadrant 1 because everything's positive in quadrant 1. All students, it's also positive here. It's negative here and it's negative here. All right, so in a minute, remember how I said we had to chop it down? All right, so again, if this idea is that I'm going to start right here at 0 and go positive first, I'm going to go positive first until I hit 1 quadrant. See how this one's positive? But I'm going to stop right here because if I continue on, I'm going to get another positive. And that's the equivalent of those regular graphs where we're not going to pass vertical line test. So the next step is I'm going to go negative this far. Okay, so these, if I am doing an inverse problem, these are the only 2 quadrants that I'm going to be in is quadrant 1 and quadrant 4. So if I give you an angle and I ask for where is this and it's an inverse, you're going to say, oh, it's a sine problem and it's positive, I'm in quadrant 1. And if it's a sine problem and it's negative, I'm in quadrant 4. Not only are you in quadrant 4, but you're going to use negative angles. So you're going to say like it's negative 30 degrees or negative pi over 4, right? You're going to actually call it negative. Here's why. If you call a 4th quadrant angle something that's positive, so let's say, just because I know we know degrees better, right? It's 360 all the way around. Let's say I went out to 330 degrees. Well, that would have meant that I started here, I traveled all the way around the circle, I entered this no man's land where there's not supposed to be any trig functions at all because it isn't a function over here, over here, over here, and all the way over here. So that's like, imagine the zombies are attacking and you're standing right here and they're like, get to quadrant 4 as fast as you possibly can. And you're like, no, I'm going to wander around the park and the cemetery and hope nobody gets me. Or are you going to just run to quadrant 4 as fast as you can by going underneath and calling it a negative? Does that kind of make sense? So it's like zombie attack. So you only stay in the regular zones that are closest to 0 because those are the safe places. You stay away from going around through those zombie zones where we're not talking about trig functions. All right, so let's just do this a few more times so you get the hang of it. All right, so if I'm doing cosine, right, all students, so I know cosine is positive here. Sine is positive here. That means cosine's negative here. Tangent is the only thing positive here. That means cosine is negative here. And calculus, so positive here. All right, so if I am standing here and the zombies attack, right, the fastest way I can get to a positive and a negative angle is I'm going to start this way and I'm going to keep going until here. That's it, right? I'm not going to go negative if I have a choice to go positive, right? So I am only in quadrants 1 and quadrant 2. And again, those are always going to be positive angles because I'm starting at the 0 and I'm moving my way up. Okay, so I only want these 2. That means that these under here are zombie zones. You don't want to stay away from these zones. Don't ever give me an angle that goes through those zones or is in those zones. Okay. All right. And then our last one, let's go and do tangent. So tangent of x. So all tangent is positive here. Students, so only sine is positive here. That's a negative. Take, tangent's positive here. Calculus. Calculus means cosine is the only thing positive here. So we have tangent is positive here, so we have a negative right here. So zombies are attacking. If I want to get as fast as I can to a plus or minus, I'm going to go up this way or down this way. I'm going to stay in quadrants 1 and 4. If I go to quadrant 4, I'm going to call it a negative angle, and I'm going to stay away from these zombie zones that either put me through quadrants 2 and 3 or are quadrants 2 and 3. Okay. All right, so I'm going to pause this a second, make sure all my mics are working. I'll be back with you in just a second.